Hi everybody, welcome to our first video test. We are going to be experimenting with flipping our classroom. So what we'll be doing for most of this unit is taking our lecture notes at home during our homework time, and I'll be giving these little instructional videos so you can write down everything that I say or have here on the PowerPoint. In this instance, I have this pencil icon, so these are the things that you want to write down, anything you see with a pencil. I'm going to start with a review of scientific notation. But that stuff you don't have to write down because it's a review. So go ahead and write today's essential question, which is, why are units important? Why might we want to convert from one unit to another? And this introduction to conversions is going to be our first topic in our new unit of stoichiometry. So go ahead and set up your Cornell note page on page 143. Remember that you can pause the video at any point as we move through. So let's take a look again at scientific notation. So remember, in scientific notation we have some format. It's something dot something something or something point something something times 10 to some factor. Where it says here that the number must be greater than or equal to 1, that's because we always have at least one digit in the one place, then a decimal point, then a tenths place, and a hundredths place. So for us in this class it will be, for example, 1.99 times 10 to the third, or 7.24 times 10 to the 23rd. We're going to keep it to that. We're not really worrying too much about significant figures. So in scientific notation, remember that numbers are written in the form m times x to the n, where m is a factor, where m is a number greater than or equal to 1 but less than 10, and n will always be a whole number. The exponent will always be a whole number. Okay, we use scientific notation to write very, very large numbers and very, very small numbers without writing all the extra zeros or all the extra places. One of the common problems I come across in chemistry is that people put things into the calculator incorrectly. So think for a moment about how you might type in an example like this. 1.2 times 10 to the third. How would you put that in a calculator? My guess is that you would either write 1.2, then the multiplier, which is usually some sort of asterisk, times 10, and then use your function buttons to add a third, or a 3, sorry, in the exponent. You might also use the little caret symbol here, this little symbol, to make the exponent 3. But the calculator is not very smart, and it just reads things right to left. It doesn't know PEMDAS, or please excuse my dear Aunt Sally. So what ends up happening is the calculator multiplies the 1.2 times the 10 and then applies the exponent to the whole thing, and you get the wrong number, because as we know, it should go exponents first and applied to the 10, then multiplied to the 1.2. So instead, I want you to write it this way. 1.2, use your exponent key, which is usually a uppercase E on your calculator, and then just write 3. And then the calculator knows that you're talking about 10 to the third, and it applies the exponent before the multiplies. So we know the old acronym, please excuse my dear Aunt Sally, but the calculator's not that smart. All right, so let's talk about conversions. Now this is what you want to write down. We're going to talk about unit conversions. It's also known as unit analysis, and sometimes it's known as dimensional analysis. So first of all, what is a unit? Any measurement is made up of both a quantity, a number, and a unit. Without the unit, a measurement is nothing. So for example, 5.5 feet. Without that feet, it could be anything. And when I always say 5.5, what do you mean? 5.5 elephants, 5.5 degrees. Without the unit, the number means absolutely nothing. So for the rest of the year, we have to remember, whenever we write down a number, to include its corresponding unit. So we use units in order to compare a measurement to some previously determined standard. What I mean by that is that units allow us to communicate information about the world around us. I could talk about an age in years. I could talk about an age in months. Both of them have a different meaning, and while they could be, 2 years for a baby could be the same as 24 months, it could mean different things. To a parent, the months are important in terms of what's going on in the baby's development. So We choose the unit based on the quantity being measured and what is appropriate for that quantity. You would use units of length if you're measuring length. You would use units of degrees if you're measuring temperature, and so forth. You would use, you wouldn't measure a person's height in millimeters because it would be too large of a number, but you might use feet or meters instead to measure someone's height. So unit appropriateness is an important factor when you're considering what measurement you want to take. So why might we convert from one unit to another? Well, you've heard about the English system and the metric system. And in the United States, we use feet and inches, but in pretty much every other country in the world, they use meters and millimeters and centimeters for units of length. So converting can be for a reason as simple as conveying information to a wider audience. We may want to report a quantity in some other related unit, and so conversion might be something we have to do. So like I was saying earlier, a baby, a 1-year-old baby, people always wonder, why do parents always say the baby's age in months? Well, 1 year doesn't give us much information because a baby who's 12 months old is developmentally very different than a baby who's 18 months old or 23 months old, who's still technically 1, but there's a lot of difference in what the baby's able to do developmentally. So choosing the unit of months conveys a little bit more information to an experienced party, like a parent or a doctor or someone. So converting units is all about changing something into an understandable unit depending on your audience. All right, so here's the most important thing for this whole unit of stoichiometry, that converting the units only changes the standard of measurement. It doesn't change the value. So when you convert units in chemistry, the value that you measure does not change. Okay, so what do I mean by that? I'm 5 foot 4 inches. Now in meters, that's 1.63. 5 foot 4 is a different number than 1.63, but inches are a different unit than meters. When you change the number and you convert from feet and inches into meters, my height still stays the same. That's what I mean when I say the value doesn't change. So throughout this whole unit, we're going to be converting between different substances like moles and grams, and it's important to get this key value, key point. When we convert from one unit to another, the number and the unit may change, but the value does not change. All right, so that's it for tonight. Just make sure you get all these things with the pencil icon down, all of these slides. You don't need to do your Cornell Note revisions or summaries. We're going to go over that in class on Monday. I hope you all have a really great weekend, and I look forward to seeing you. Take care.